Hello again, everybody, and welcome back. We are now going to finish up 9.A.3. This is the second part of 9.A.3, doing some more trigonometric equations algebraically. So we looked at a few yesterday, and feel free to go through some of those answers. We looked at the different solutions for solving our trigonometric equations. Got a few more that I want to do here before we give you an assignment. So this one here, it says find the solutions of radical 3 sine x is equal to cosine x. So what do we do with this type of problem? Because it looks like we have a sine and a cosine on the same side. So also our domain's a little bit different. We're looking for x being between 0 and 360. So it's in degrees, not radians here. So what do we do? Well, in this case, let's go ahead and divide both sides by cosine. It's a little tricky to get started here, but if I divide both sides by cosine, what do I get? I get radical 3 sine x over cosine x equals cosine x over cosine x, right? And, well, cosine x over cosine x, well, that's just going to be equal to 1, right? And then what do I have over here? Radical 3 sine x over cosine x, right? Well, what is sine x over cosine x? Isn't that just tangent? So this is going to be radical 3 tangent x is equal to 1. Now I can divide both sides by radical 3. Tangent x equals 1 over radical 3. So now my question is, where on my unit circle do I have tangent values of 1 over radical 3? Well, there's going to be two. It's going to be in the first and third quadrant, and I'm going to go ahead and kind of scroll down here to this diagram they already have drawn up here, right? This is sine over cosine, so the 1 over radical 3 and the 1 over radical 3. This is where we have tangent values of 1 over radical 3, and that's going to be at my 30 degrees and at 210 degrees. So my answer for this problem, x is going to be equal to 30 degrees, and x is going to be equal to 210 degrees. And we had them in degrees. Why? Because the x value is between 0 and 360. So next we have an equation that looks a little more involved than we've seen so far. So the first thing I did was, this is a little bit different than the one in your book. I went ahead and they did 0 to 6 pi. I'm just going to do 0 to 2 pi to keep it on just one revolution of the unit circle. So let's see, what am I going to do here first? Well, I've got this radical 2 cosine of x minus 3 pi over 4 plus 1 is equal to 0. It looks like a bunch of things that we've seen all put together so far. Well, let's start by subtracting the 1 over, okay? So radical 2 cosine x minus 3 pi over 4 equals negative 1, right? And then I've got my radical 2. Let's divide both sides by radical 2. So cosine of x minus 3 pi over 4 is equal to negative 1 over radical 2, right? So that's what I have so far. So negative 1 over radical 2. That's also the same as negative radical 2 over 2, right? If you use either one of those. So where on my unit circle do I have those values? Well, remember, before I look at those values exactly, because I've got that x minus 3 pi over 4, instead of looking at 0 to 2 pi, I need to change this a little bit, because this x is now going to be x minus 3 pi over 4, right? So because it's 3 pi over 4, I got to subtract 3 pi over 4 from the 2 pi, and I got to subtract 3 pi over 4 from the 0, right? So that's going to change just a little bit. So what does that change my range to? That's going to be, or my domain is going to be negative 3 pi over 4 is less than or equal to x, and that's going to be less than or equal to, well, 2 pi minus 3 pi over 4 is going to be 5 pi over 4. So that's going to be the values I'm going to look for. So if I draw my unit circle out, again, so where does cosine equal negative radical 2 over 2? We know it's going to be this guy right here at a 45-degree angle, and this one here at a 45-degree angle. And I'm going to start looking at negative 3 pi over 4. So what are my values going to be, my answers? from negative 3 pi over 4 to 5 pi over 4. Well, negative 3 pi over 4 isn't that going to be right here? That's going to be where I'm starting. So my first one is right there, which is negative 3 pi over 4. That's one of my answers. And then I'm going to go around all the way to 5 pi over 4. So I'm going to go around. Here is 3 pi over 4. That's going to be another one of my answers. So 3 pi over 4. And then we go down to 5 pi over 4, which is another one of my answers. So 5 pi over 4. So I started from here and went all the way around to here. So I was at negative 3 pi over 4 is where I started. I crossed 3 pi over 4, and then I ended up at 5 pi over 4. And that was because my the range of values that I was looking for x was in between negative 3 pi over 4 and 5 pi over 4. So those are my three values of x that I'm looking at so far. But remember, this was, whoops, and I drew something wrong here. This should still say x minus 3 pi over 4. So those values of x that I found, it wasn't really x, right? That was x minus 3 pi over 4. So now I have to add 3 pi over 4 to each one of those. And what am I going to get? I'm going to get a 0. 3 pi over 4 plus another 3 pi over 4 is 6 pi over 4. And then 5 pi over 4 plus 3 pi over 4 is going to be 8 pi over 4. And now those are my final answers. And again, if you look at the answers here, what they did was, notice how they had the answers when they added the 3 pi over 4. They had 0, whoops, they had 0, 6 pi over 4, which they reduced to 3 pi over 2, and then 8 pi over 4, which was 2 pi. Now remember, we only did 0 to 2 pi. They went ahead and kept going and did a whole bunch of other ones all the way up to 6 pi, but I changed our values for this problem to make it a little bit easier. So let's solve one more equation before we stop here. What if we have something in a quadratic form? This is actually easier than it sounds like. So I have 2 sine squared x plus sine x is equal to 0. How would I do something like this? Well, we're going to factor just like we would a regular quadratic equation. So what's common here that I can pull out? In this case, wouldn't it be sine x? If I pull out a sine x, isn't going to leave me with 2 sine x plus 1 is equal to 0, right? I factored out. And then all I have to do is look at, again, we're going to be looking at 0 to 2 pi, so just our regular unit circle. I have to look at where does sine x equal 0 and where does 2 sine x plus 1 equal 0. It's become easy, right? Where does sine x equal 0? Well, x is going to be that at 0 and pi. And this is going to be what? 2 sine x is equal to negative 1. So sine x equals negative 1/2. Where does that happen? Well, we already saw earlier. X equals 7 pi over 6 and 11 pi over 6. And those are my answers. So my answers are going to be 0, pi, 7 pi over 6, 11 pi over 6. What about this? What if we have a quadratic where we have cosine squared x, 2 cosine squared x and cosine x minus 1 equals 0. Let's try this. If I told you that, I'm going to do a substitution here. U is equal to cosine x. Then wouldn't this be 2u squared plus u minus 1 is equal to 0? I'm just going to get it into a form that we looked at. If we had to factor that or unfoil that, wouldn't you say we have what? We have 2u and we have u, and I have, this would be what? Minus 1 and plus 1, right? And wouldn't that be 2u squared? And then that'd be plus u minus 1 when I factor that out, right? Equals 0 when I FOIL that. So instead of u, put cosine back in now. So I'm going to have 2 cosine x minus 1 times cosine x plus 1 is equal to 0. And now I just set each one equal to 0 like I did with the other problem. So I have 2 cosine x minus 1 equals 0. So 2 cosine x equals 1. Cosine x equals 1/2. Where does cosine x equal 1/2? Where in my unit circle? At pi over 3 and 5 pi over 3. Got to know our unit circle. And then over here, cosine x plus 1 is equal to 0. Cosine x minus 1 equals 0. Oops, sorry. I should have said cosine x equals -1. Where does cosine x equal -1? At x equals pi. So my answer is pi, 5 pi over 3, and pi over 3. And those are my answers. I think I have them down here. Yep, you can verify them with the unit circle and go a little bit further there as well. So that's it. I picked out just a few problems, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 problems here on this section. And this is the second assignment for your section 9A. So check those out. Again, if you have any questions on these, I know I went through some of them a little quickly, so feel free to watch the video explanation again. If you have any questions, please let me know. I'll be happy to answer them in the chat, or I can make a couple of video answers of working out some problems, or feel free to email me as well. I hope all is going well. Good luck with these assignments. Again, let me know if you have any questions. Check in with me on the message boards, and we'll talk to you soon. Take care.